Alright, well, here we're doing 9.2. We're doing translations. Translation is nothing more than a slide. I like to think of the word slide when I think of translation. That's all we're looking for in these four pictures, just like the last example. So we draw that imaginary line in between a couple of these guys. We look for the ones that are sliding. And the only two that are really sliding are B and C. You can see how this shape here for B, this blue one, is exactly the same as the red one. It just slid down here. And the same thing with this guy over here in C. We have this blue one slid that way, or this red one slid up and that way, and they're the exact same shape. A, for that matter, would be reflections, right? In the last video that we just watched. And we're looking at D. D is something all around different. Those are two different shapes. If you look closely, they're two different shapes. So we're looking for something to slide. When we're thinking about what our picture should look like, it should look the same. It really shouldn't look any different. It should just have slid over somewhere, one way or the other, up, down, something like that. Alright, and our first and only example for translations, because they're so easy, I left us to plot our points just for some practice. So we're going to plot those first points here, D, E, oop, my bad. We're going to plot those points D, E, and F. And let's start off with D is -3, so to the left 3 and down 1. So we're going to end up right here. I'm going to call that guy D, right? And then E is 5 over to the right, -3. So that's E. I don't like that E. Much better. And now we have F -2, -2. And we have F here. So we connect those dots. And we have some sort of triangle there. We're just going to slide that triangle, and we're going to have to figure out, what does this vector mean? Along the vector -2 and 4. Do not be the person to plot 4 points, D, E, F, and whatever this is, and have no idea where you're going with a quadrilateral. Please at least read the directions. It does say triangle after all. 1, 2, 3 points for a triangle, not 4. So this fourth is our vector, and we're just going to move our other points, and we're going to use it. -2, is that left or right 2? Well, negative goes to the left, so we're going to go left 2. I actually like to write these guys right here, just left, put a little arrow there. And then 4 is up 2. 4, my bad. Up 4. So we're going to take our D. I'll get you a different color here to make this easier to see. We're going to take our D right over here on our coordinate plane, and we're going to move it 2 to the left, and then up 1, 2, 3, 4, and put our point right there for 4. We're going to call that guy, right, the same as before, D prime. We're going to do the same thing for F then. F is going to go 2 to the left, 1, 2, 3, 4, and end up right there for our F. And we'll call that guy F prime. And then our E way over here, 1, 2, 1, 2, 3, 4, can end up right there for our E. E, don't forget the prime, connect the dots, and you notice our triangles look very similar in this case with my drawing. But the whole picture just slid over 2 and up 4. Now, that's the easy way. The hard way, I guess, if you will, would be we have to figure out the new points. And then how did we get to those new points? So our D prime now, our new D, right? Our D prime is actually, let's move this guy over a little bit. Actually, our D prime is -5, +3. -5, +3. And our E prime, Our E prime over there is what, 3 and 1. And our F prime, move this guy a little bit. Our F prime over there is -4, 2. If you look at those numbers and you match them up to our original points, there's no real correlation like there was in the last section where we could flip the numbers, flip an X, flip a Y, flip a sign. We got to look at those. We have to figure out how did we get there, and here's the math behind how we got there. We're going to take those original points. I'm going to shrink this guy down and move it a little bit more. We're going to take those original points. I'll use D as D, -3, -1. And we're going to take that vector that we have, this -2 and 4, and we're going to put it right below it, -2 and 4. And that's the vector, and I'll put it like this. So we see that's our vector. And what are we going to do with those numbers? If you look at your new D, our D prime, we're going to add. We're going to add those numbers. I'm going to get rid of this right here, and I'm going to put that plus right there just so we know, hey, you know what? We're going to add those two. When we do, we end up with -5, 3. That's our D prime. I would hope you see that this matches this right here. And we would do that for each one of those examples. Just add our vector to our old points, and we come up with a new point.